Good morning again. Time domain sampling. What the fuck is that? What does that mean? Why is that one of the fundamentals of the knowledge that science gives us? Time domain sampling. Simplest example of this, especially if you're older, is great example. Photographs. Go back and look in the family photo album. And maybe, if there's time and dates on those photos, might be on the back. Might have been printed at processing instead of digitally time stamped on the computer file, right? This is before computers. So you took a photo, and then 10 years later you took another family photo. That, in comparing the two photos, is a form of time domain sampling. You're looking at a piece of yesterday, a photograph taken in less than a second, decades ago, compared to a photograph taken in less than a second, sometime later. That's the simplicity, I suppose, of time domain sampling. And that's the complexity of time domain sampling, because when you go look at the photo, you can see artifacts of the time that remind you of being there, or memories of that box that you saw Grandma and Grandpa had for that old toy. That's time domain sampling. That's a simple stretch of your mind you're probably not even conscious of. You just look at the photos and smile or cry, depending on the memories, right? There's a soft time domain sampling. Now, I pointed to the time and date the photo was taken. And if you were there, you add your own location to it. If it was digital, today's photos, and you had GPS turned on, the exact location, the time, logged out to probably 6 or 8 decimal places, is stamped on that photograph. The more you can relate that to an exact time, the more the objects in that photograph might have relevance or meaning or historicity. This is the evidence of photography. This is the use of photography. This is what we did, what we do, what we still do now with satellite imagery. Compare yesterday to today. Compare today to today. The 4 months of training was in the same location professionals were taught to analyze spy photographs. We were learning how that spy photograph has distinct, specific meaning in time. That's the fixed variable, right? It's fixed because we know when the photo was taken. But time is drifting away from that date and changing things. So there's time domain. Now let's jump into radar time domain. That radar set is sending out a pulse, and the exact time of its reflection back to the radar set. The radar set's spinning. It has an angular component to its measurement, so we know exactly what angle the radar set was at when it swept by. And because of that slight spin, that slight movement, the time we sent that pulse out to the angular momentum of that spinning radar dish is calculated and computed and checked on and verified. And it's part of what makes sense of that signal, how far away the signal is. Then how strong that signal is tells us about the size of the object. and some other very discrete things to do with the reflectivity of different elements in the atmosphere. So all of this, the angular momentum, lot of vector physics type of math applied to do the calculations to know the signal you sent out at a 1 degree rotation of the antenna is the signal that's reflected back at a 1.07 degree rotation of the antenna. And this we know. This we time slice as small and as fine and as granular as we can. That time is based on a clock that's been running since our history shows the clock began, and that's daunting. Then to add confusion, you go back in, and back in time, Earth used to have a 22-hour day. What does that do to time itself? Nothing. And yet to humanity, huge impact. So this time domain sampling, this exact measurement science of the physics of mechanical rotation, of the physics of wave propagation through the atmosphere, the physics of processing a return signal in megahertz of a frequency to something you can visualize on a radar screen and see and understand. If this doesn't amaze you, then Merry Christmas. Because it's deep. And the deeper you dig, the deeper it gets, and it's a bottomless pit. It is one of those rabbit's holes. Now, these are conversational tricks as well, to mention a rabbit hole and then walk by it. But there are folks that play in the rabbit holes and are more than willing to take a tour in the rabbit holes along the way, to share some of the doors that they opened that you might not have had an opportunity to, that you walked by through your life in the time that you've experienced this planet. So this time domain sampling added to the time, the natural time of history and geology and this planet spinning for eons around this sun, around this galaxy that was created some long time ago. This is where our heads are. This is where our children's futures are looking to, exploring Mars, exploring space. The potential is ours. The future is ours. To blame it on anybody other than what's in the mirror is kind of a challenge. So there was time domain sampling, a poor introduction. But if you're interested, if you want to know why I can speak to that and wonder about the 4 spectrometers, high particle physics measurements being done by the Parker Solar Probe, and what those solar waves mean to the future of this planet, and what that understanding is. The fundamental particles of the sun could be harnessed for more good, more better. Voting isn't going to fix this. Voting for the right person can fix this. Not voting because of political nonsense is kind of what they want. They want their voters, their base. Oh, too long. 9 minutes. I can go into the physics of this time domain stuff if you have 100 hours. I'll put it out there.